What's happening, all you cool cats and kittens? This is Mr. Steve checking in with you guys here with page 4 of your packet. Page 4 is the first page that has any work to do on it, so I'm skipping directly there. Now, this is hopefully the first of many videos that we're going to have out there that explain how to do certain problems on your packet. This one is balancing chemical equations. So balancing chemical equations is all about making sure we have the same amount of elements on each side of our arrow. So here for number 1, and again, this is on page 4 of your packet. On number 1, we have 2 nitrogens right there. We only have 1 nitrogen right here. Remember, if you don't see the subscript, it means that the subscript is 1. So 2 nitrogens here, 1 nitrogen there. I can put a coefficient of 2 right there. Now I have 2 nitrogens right there. Great. When I put this coefficient right there, I also change the amount of H's I have. So if I do 2 times that subscript of 3, I have 6 H's on this side. So now that I have 6 H's on this side, I want to have 6 H's on this side. So I can put a coefficient of 3 right there to get 6 H's. 3 times 2 equals 6. Now let's just double check, make sure we got the right amount on each side. We got 2 N's here. We got 6 H's here. We got 2 N's here. We got 6 H's here. We are good to go, baby. Yes. Yes. All right. Great. Next, we've got ourselves a decomposition. So what we're going to have to do is the same thing. We're just going to put in coefficients that will make this a balanced chemical equation. So let's find what's not balanced. I got a K right here, 1 K there, 1 K there. Beautiful. 1 Cl here, 1 Cl there. Beautiful. 3 oxygens here, 2 oxygens here. Not beautiful. So we've seen this type of problem before, and this is where a really handy trick can come in. When I'm trying to balance out oxygen, sometimes it's okay to use a decimal number. Now, that's not going to be in your final answer, but it will help you get there. So we've got 2 oxygens here, 3 oxygens there. What number times 2 gives me 3? That's right, 1.5. You are so smart. The smartest. Good job. All right, 1.5 times 2 equals 3. Great. Now I have 3 oxygens on this side, 3 oxygens on that side. But as we know this, we cannot have a decimal number as my coefficient for my final answer. So what I'm going to do is I'm going to multiply every coefficient by 2. And that will give me my final answer. So the coefficient that belongs right here is you guessed it, 2. The coefficient that belongs right here is, you guessed it again, 2. And 2 times 1.5 is 3. Well done. You haven't lost a step. So good. All right. Next one, number 5. Number 5 is a little tricky here because we see that we have a polyatomic. Anytime we have something in parentheses like that, we call it a polyatomic. So let's see. On the opposite side, we don't have another polyatomic. That's weird because we usually know that polyatomics stick together. Well, here comes time for another one of our handy dandy tricks. This H2O, well, I'm going to call it something else. It's still H2O, it's still water, but I'm going to call it HOH. There's still 2 H's and 1 O, it's still H2O, but I'm just writing it a little differently. Now I see that I've got an OH on one side and an OH on the other side. And I've got an H on one side and an H on the other side. So now I'm going to treat the OHs like one individual unit that does not ever break up. And I'm going to treat the H's separately. So the OH is now separate from the H. That's going to make it a lot easier to balance. I'll show you what I mean. I've got 2 OHs right here and only 1 OH right here. So I'm going to put a 2 right there. Now that means I have 2 OHs and 2 H's. Cool. Well, that means since I have 2 H's right there, I want to have 2 H's on this side. Wonderful. When I put that 2 right there, I also have 2 Cl's. Okay. Good to know. If I have 2 Cl's on this side, I must have 2 Cl's on that side, which I do already have. Now, the only thing that we haven't talked about here yet is PB. I got 1 PB on this side. I got 1 PB on that side, and we are good to go. It's actually Easter today, so enjoy this little bunny. Oh, gosh. I don't know. Happy Easter. All right. Last one. Number 6. Look at that. We're all the way through number 6. I'm doing your homework for you. How nice is that? That's tight. You're welcome. All right. Number 6. Cool. So, look at this. We've got a polyatomic on one side. We know because it's inside the parentheses. But I don't see one on the other side. At least, not yet. Sometimes they don't put parentheses around a polyatomic when there's only one of them. So, we go ahead and we put in the parentheses. That's totally okay to do. If you see a polyatomic and you want to put it in parentheses, that is absolutely fine. So, let's check it out. We got 1 SO4 on this side. We got 3 of them on that side. So what do you think is going to go right here? You're right. It's 3. 3 SO4s, 3 SO4s. Terrific. When I put this 3 right here, though, I'm changing the amount of Ks I have. So 3 times 2 equals 6. 6 Ks here, I want 6 Ks there. Well, now I just changed the amount of BRs I have. I have 6 BRs on this side, so I need to have 6 BRs on that side. Coefficient of 2 fixes that problem because 2 times 3 equals 6. Now I have 2 ALs on this side, and I have 2 ALs on that side, and we are done. D-O-N-E, done.